Hello, sir. How you doing?
All right.
All right. How's everybody doing tonight? All right. First thing I want to talk about is up on the board, Tech Expo, Tuesday, October 23rd. I have some posters up here. If you do work at a place that you think you might be able to hang them up, or coffee shops, or wherever you're more willing to take some. iPad Mini, 4 credit hours. To sign up, you can go to myreceipt.org, or I'll just go real quick to show you. You go to myreceipt.org. It should pop up. One of the first pop-ups there. Banner ads should be for the Tech Expo. And when you click on that, you should be able to register. So as soon as you click on that, it'll take you right to Eventbrite to where you can register. Doesn't cost anything. Just ask you to register early if you haven't already registered already. A couple weeks out, we are going to be giving away an iPad Mini and 4 credit hours. So that's not too bad. I've already got all the bags today and the nice Rock Valley College pins, and we'll be doing some other cool fillers in your bag. Sign up, or when you register, will be from 5:30 to 6 is registration, and I will pull up that agenda real quick. So the agenda is 5:30 to 6. Well, first of all, dress attire is business casual. So registration is going to be open from 5:30 to 6. Bring your Eventbrite ticket with you. You'll get a ticket in return for the drawing at the end of the night. So make sure and bring your Eventbrite ticket with you. And it should have emailed it to you. And it will remind you 2 days before. So that Sunday before, it should remind you. At 6 o'clock, I'll welcome everybody. Keynote speaker Michael King will come up till 6:30. He's going to talk about local job opportunities in Rockford region. He works for Rockford Workplace and does hiring for local companies, and specializes in IT companies that need IT skills. And so he's a great guy. I've known him for a number of years. He works with Lorraine Logan here in town, which you might have heard Lorraine's name around the news over the years. She's heavily involved in the community and a lot of different endeavors. I invited her first, but she was busy, so she asked if Michael could do it. I was like, yep, that'd be awesome. Connection time from 6:30 to 7:45. You'll walk around the tables, and there'll be, right now, I've got a count of 12 or 13 companies that'll be there. And you'll go to each table, talk about their opportunities, internships, skills that they need. There'll be resume building helps there as well. All of CIS faculty will be there as well to help. So if you're needing to talk about course stuff while you're there in the future, Stephanie will be there to talk to you if you need help on anything. And Sylvia, Eric, and Jim will also be there as well. Door prizes from 7:45 to 8, and you got to be present to win. And we will, I think Stephanie and Jim's going to help me on that. So you have to keep your ticket for that one. And then these two for sure will be given away, but businesses always give away other stuff too when they come. So there'll probably be a number of little things. I think, if I'm not mistaken, don't quote me on this, there might be a couple little Ozobot robots in there, little fun robots maybe that'll be given away. So a lot of fun stuff. But the main thing is you get to connect with local employers that you could be working for in the future. So that's kind of cool, right? This is our 3rd year doing it. And I had the original idea about 4 or 5 years ago to do it because there's so many companies that are in Rockford that students aren't aware of that are here that are really good tech companies. And I think sometimes tech companies aren't aware of the talent that we have as Rock Valley College students, you guys, and gals. And so, anyway, it's kind of best of both worlds, I think. So definitely sign up, invite others. That's awesome. And there will be food there, by the way. I don't promote it, but there will be food. I'll have pizza there. We always get foot traffic though that comes in. So questions on Tech Expo. Cool. Next thing I want to talk about is in summer session 1, believe it or not, we'll be here before we know it. Has anybody heard of Internet of Things before? Internet of Things. Basically, in the little video here showing on our website for the course, it's 4 Saturdays. But basically, the Internet of Things is any device that can be connected to the internet to either be viewed, monitored, or controlled. So it's everything from lights in your house to doors to garage doors to sensors on your dryer to tell you when the dryer's done, to your vehicle telling you your gas is low, your tires are low. Let's go in healthcare. An example I'll give you is I use a sleep apnea device, and so inside that little sleep apnea device is a cellular chip that sends data every day to my doctor. They have them for pacemakers. A whole bunch of medical devices now have IoT built into it for communication. And so summer 2019, it's a little ways off, but something to plan for. It's a little different summer course you might be used to. When I do teach summer 1, I always do it on a Saturday, and it's like from 7:30 to 8 a.m. is check-in, and then from 8 to noon is the actual class time, and noon 12:30, something like that. And then we eat lunch every day, every Saturday at the end. And so that's the concept, 4 Saturdays in a row. So 4 Saturdays, and you will create 4 different projects. So the first project is a motion detection send notification apparatus. And so basically what that one is, I'll click on this to show you. And we've all had notifications for everything under the sun, right? This is just a device that uses a photon and a sensor for notification for movement, and sends it to your phone. There's a sensor right there. And the photon connector goes through the sensor, and it comes back and will give you a notification. So a lot of different steps on it, but basically the end result is this right here, what it's going to look like, the little phone there. Second is controlling the servo, which is basically just a robotic arm. And click on that. So this one's kind of cool, I think. This is the device you'll be setting up, and basically it has in it a photon again, and a service that basically works with a photon, and it's a Wi-Fi device you're seeing on the left, connected to the sensor, which is right here, and that's a servo. And you'll notice on the web app, when you turn the colored wheel, the actual wheel turns wherever it's located. And the way it works basically is you have a couple tools that are involved in this. As you've got, let me pull it up to show you, not to get too technical, but you guys don't mind. Kind of cool stuff anyway. I'll pull up my GitHub to where it has all my stuff in it, to where it's a little easier to view it.
It's this coming summer?
Yeah, this summer 1, or yeah, it's called summer 1, I think. So the service is Particle. That's what always slips in my head. They just changed it. It used to be called something else. I'll pull it up. So Particle is an awesome company. What Particle is all about is like the recent Florida floods, right? Everybody's familiar with that. Even as of this week, there's tons of companies and individuals creating IoT devices to help with valves, uh, exactly where to put exactly where to put valves before the rain hit. All of these were Internet of Things devices that were created for the tragedy that happened. And so they've got different products though. The one we'll be using is the Wi-Fi device. And I'll click on this little kit here. Each one of the projects in total only cost about 25 bucks per project. And what's cool about it is the Particle company works with a cloud service. They give you 100 devices that you can connect to this cloud service totally free. So once you buy the hardware, set it up, there's a little coding involved, a little hardware setup involved, connecting to your Wi-Fi at home or work, and then you have your Internet of Thing device. So this one we'll be using here, I'll show you. The main one that we'll be using, scroll down and find it here. I want the Wi-Fi, let's go here. This one right here, this photon kit's 29 bucks. The individual photon's only 19. Now I'll bring to class a whole bunch of what's called breadboards. These breadboards are, I'll click on this, it's what you see underneath the photon. And the breadboards allow you to connect your sensors to the board. And then that photon device is what's connected to the Wi-Fi that you can connect to an app. You can connect to if this and that. You can connect to a number of different services. Connect to Google spreadsheet. And so when notifications happen on a sensor, it sends it to that. But very reasonable. The one we'll be using for all of our projects will be this one here, this $19 one. I'm trying to get money to where students don't have to pay for anything. In total, all 4 projects will only cost about $100, and which is pretty cool. And then you can use it, over and over again. So the second one, again, was the Wi-Fi controlling with the WebSock app. The third one, you guys have heard about like Internet of Things on like wearables, like maybe earrings or bracelets or whatever. This shows how you can do that. All 4 of these kind of a small scale can show you what you can do on a large scale. And so this was called an Adafruit NeoPixel using Python and JQ widgets. Now all that sounds confusing, but it's really easy to use, and once you learn it anyway. And the way this works is this app can work on any type of device, by the way. It's a web app, so it can work on iOS or Android. That device on the left that's lit up can be at your house or in Africa or anywhere. It just has to be connected to Wi-Fi. You notice the breadboard here, and the pins are plugged in the breadboard. Here's your photon. This little USB mini device is what's powering it. And by the way, you can buy, what's cool, you can buy a little battery or like rechargeable lithium in place of this USB. The rechargeable lithiums are only like 10 bucks, and the recharge lasts like a week on these devices. So literally you could take the rechargeable power source, put this that's where the wearables come in. You could put it on any type of, clothing or whatever, jacket. And there's even some folks I've seen that use a smaller version of this to make earrings, to make the earrings change colors and things of that nature. So that's, again, is it novelty, some of this stuff? Yeah, but you can actually see a lot of practical applications as well for use, I think. And so the next one is temperature reading from anywhere. And so on this one, it's basically, again, a photon. All of these are using the photon particle, which allows you to connect to the internet. Because up to this point, before the photons came in, no, that's all right. Up till photons came into play, there was Arduino was the only thing on the planet that you could use. But now that particle photons are on board, these guys are the ones that allow you to connect the devices to the internet. And so here again is your photon device, your power source. These wires here is what connects the heat sensor and the humidity sensor. And so for this one, it's a photon, the sensor, which is this Adafruit S1 SI7021, a breadboard that's solderless. It just uses these plugs can be moved wherever. And you'll learn in the class, there's most of these are going to be using the same slots for most of the communication, but some of them are different. But you'll notice there's hundreds of different slots they can go into. But you'll learn all of that for each one of them. So that one is the last one we'll be doing, which is measuring temperature. On that one, on the end result, we'll save this one to a Google spreadsheet. We'll also show you how you can notify using a service that I've been using for a while here. It's totally free. If I can find it here. I think I saved the URL to show you. Push over, there it is. Pushover is a website that you can sign up, and it's a mobile app, Android and iOS both, that lets you set up for free notifications. And so coupled with Photon, the sensors, and Pushover, you can set up notifications at no cost, basically. All you need to pay for is the device and the sensors. Some of these sensors are like $8. The Photons are each $20. So minimum price is usually about $30 for any type of Internet of Things device. Maximum might be 50, and that's it. Yes. Anywhere, yeah, you can put it anywhere. The one that we've used in the past is we've used it in the office to motion sensor for places people aren't supposed to enter, like for IT purposes. And then when the motion sensor triggers, we actually have it connected to a camera that takes a photo. And again, the photo sensor or the photo device, it's only like $10 to set that up. And you can use the same exact photon along with the photo sensor, and the motion sensor can be used in one breadboard photon. So that package only costs like $40 for it. So what I'm hoping is at the end of the 4 weeks between these 4 projects, you can take that and run with it. All of them you can apply, like the heat one, that can be applied to attaching it to a dryer vent. And when the dryer is complete and the vent goes to a certain heat level, it triggers to say dryer cycle's complete. That would be one example. For motion, you could take that to the next level and do a doorbell or door notification that somebody's coming up towards your door. Add a camera to it. And one of the things I'm thinking about adding to the motion one, and I might still do it, is the camera, because that'd be kind of cool. Not only get notified of motion, but get a snapshot in an email of that notification. And it's not gonna be too hard. Not much more money. It's like $10 more. So thinking seriously about adding that, because this is still in flux, kind of. But I wanted to show it to you. So what do you guys think? Yeah.
How many credit hours left?
This is only 3 credit hours. 3 only. Yep. And 4 Saturdays. And the website, and it's still in formation, so it's still working on it, but I wanted to get it up and running. And by the way, there's a new domain I'm using for this. It's .app, which right now there's a sale on .app for $16.99 a year. And it comes with SSL encryption built into it, which .app, you have to have encryption on it. You don't have to pay extra for it. It's only $16.99 a year.
I love this stuff. I took the Arduino U and made a rover out of it.
Oh yeah, cool.
You're able to control it from the computer on any network.
It's a lot of fun, right?
It would rove wherever the network
is. It's a lot of fun. It's a blast. Because everybody has heard of it and everything. You use it, but for most consumers, even the Ring doorbell is like, I think, $100. You can create one of those with the right parts around $35, $40. And yeah, and you know can and the service that Particle gives you up to 100 devices you can connect at no cost. And so there's no reason. There's only 250,000 developers currently connected to Particle, which surprises me. But what that tells me is that people are not aware of it globally. And so I'm hoping, and I searched the area here, there's nobody teaching Particle or teaching Internet of Things with Particle in conjunction with Adafruit and the notification. So hopefully it'll be a unique training as well. If nothing else, we'll have a lot of fun for 4 weeks, creating a lot of cool projects. And so questions on Internet of Things. Again, the website is IoT or rbciot.app, rbciot.app. And I will be updating this continually. So if you do have questions, that first video is kind of cool, I found, of kind of a guy getting up in the morning, getting his breakfast, getting the news, calling somebody, the door opens automatically, he doesn't have to touch it. Stoplight turns green, elevator opens automatically. Elevator opens automatically here. And then when he's running, everything's being kept track of, his location and all this stuff everybody's familiar with. It's, you know, something we see all the time and you might use all the time already. He's in a grocery store and a grocery list is updated from his refrigerator. Has a sensor in there telling him it's out of milk or whatever, or bread or butter or whatever. Again, it's a dramatization of it, but you know, definitely we're getting to the place to where, and it helps save time too. An example, Harley Davidson increased their productivity by 60% by creating Internet of Things, implementing it in their warehouse for inventory. Because instead of a person scanning everything, as shipments come in, there was scanning devices that would scan and take pictures and tag and put it in the database without a user having to do anything. So like from the UPS truck to the shelf, all automated. Internet of Things also can help with anything data related, not just hardware, but it could be time of day, location that you're at. An example, workplaces use Internet of Things to determine where all their people are in their fleets, and then can tell who can get there the fastest from that location. So a whole bunch of different things to healthcare, industry, education. So hopefully I'm hoping this fills up quickly. I think it will. It's a pretty popular topic, and we've been asked to teach it for a while. And so, what do you guys think? Pretty cool? Think about maybe taking it? Maybe? I know you're graduating. You're like, I'm going to be off at least a semester. So anyway, think about it. If you have questions, let me know. But it's definitely a huge, and I didn't read all the stats on the page. On the webpage, there's tons of stats you can read that I believe is important information. One of them, that the first Internet of Things device was actually an ATM back in the 70s. And so it's the first technically real example of one. And the latest would be Google drives their autonomous cars for testing 10,000 miles a week right now is what their average is. And one of the big concerns you might have heard of with Internet of Things, we'll talk about it in the summer session, is security. It's really open right now, but it's open on purpose because it's still in development stage and people's figuring out what they can do with it. And so a lot of companies are concerned because of the security ramifications, but I think that will come. But I kind of like how it's working because generally in IT or anything technology, we're not allowed to do what we're doing now with Internet of Things. The government doesn't allow it until after big companies have had a time to play with it. This is different because it's kind of a grassroots movement that individuals and engineers and networking people and students are creating some pretty awesome things before industry ever gets it. And I think that's the way it should be done because you're not stifled by red tape, basically. Sky's the limit on what you can do with the technology. So anyway, I think it's going to be exciting to see where it goes and to where Internet of Things takes us. And my big thing with it is that if it helps people save time and spend more time with their family and things like that, I think that's, to me, a big plus, definitely. Okay, so I switched, by the way, the chapters this week. We did have originally chapter 7 in this week. I moved it, chapter 10. So if you've already done the review questions, you apologize for that. But we're doing 10 this week because it should have been 10 anyway, but it wasn't. It was 7 for whatever reason. But if you look on the overhead, tonight we're going to be doing remote access. We'll go over VPN and remote access. We'll end with the lab, what your take home is, because your take home this week, your take home or your lab is a take home. So you won't need to put your name in there. You'll have a whole week to do it, and you'll find out what that is in a second. Next week, and we talked about this last week, is research night. Research night is the night that you will begin your research paper. Now, I know everybody's probably already got all your research paper done and the outline's finished, and you're just doing some final touches on it. Just kidding. I was in college too not too long ago. And so this night I've always done for the 2 classes, which is my 110 and 130, where I require paper and presentation. And it might have been a while since you've done a paper. So this class is to help you. This class time is to help you work on your paper. So I'll click on this little Prezi to show you a little snippet of what you'll be doing. You'll be watching this Prezi again next week. And it just goes through some helps to help you create a paper. And so I'll show you that real quick, create a presentation. And you'll go over it again. It's not real long. So step 1, like every English teacher's always told us, right, all our life, is what? Create an outline. And if you're like me, when I was in college, I don't need to create an outline. I can like just do this in my sleep. I can like I can type a paper like overnight, which I generally did the night before it was due. So I know nobody else is like that, but well, maybe just me. So create an outline. That's what we're going to start next week, hopefully. Here's my suggestion, okay? This is why I ended up doing a lot of things in college. And when I took my bachelor's and master's, both I ended up doing. I got better when I took my master's. I was a little bit more disciplined with my work. But anyway, 4 to 6 points is what I suggest for your paper, because your presentation is only going to be 10 minutes. Your presentation is 10 minutes. So your paper is not that long. It's 5 to 7 pages, double space, except for quotes. So it's not a lot of data. So 4 to 6 points. Example would be like Wi-Fi security, introduction to Wi-Fi security, why I chose this topic, history of Wi-Fi, types of Wi-Fi security, the most secure Wi-Fi, the future of Wi-Fi, and then conclusion. And my steps got messed up on this, looks like. So you'll start out with the outline, number 1, whatever that might be. Might be introduction, might be the history of whatever it is you started, why you started it. I've been collecting data just on that point only. And force yourself, this is important, not to format the text as you're collecting data. So you're just collecting data from internet websites, putting them in a Word document. Under that website information that you gather, you put the URL of where you found it, because you'll need that here in a second when we talk about your works cited. Copy and paste the articles from the web, because most of you will get it from that. I doubt if you'll get many from books and magazines, but you might. But most of yours is probably going to be from the web, I'm guessing. Along with the source information and saving the document. And this is just an example, but I always did it this way. I would do whatever the outline point was. I would do it like point 1, point 2, point 3, point 4, so on and so forth. And when I was done researching, all of my points were in separate documents, if that makes sense. And you don't have to call it point. You can call it whatever a word in your outline is or whatever. That's just an example. Does that make sense? So all of your data is going to be in each one of your points during your collection. And here's a big one. It's going to be harder for some of you than others, is the formatting. Do not format anything. You're just collecting data at this point. You're not formatting a paper yet. That makes sense? So you're collecting data is the second step. Third step is edit, organizing, and formatting. So you've collected all your data. Then you'll start grabbing that data and putting it in a new document. and bringing that research in to all the points you collected. And then after you format it or organize and format it, then pass it on to somebody else to proofread. Okay. And that's important to get somebody's set of eyes to look at it besides yourself. And hopefully somebody that's maybe better than you with grammatical things, possibly. I did that all the time, so I still do. And so don't be prideful and don't ask for help. So have somebody look at it, go over it. There are places on campus that you can get help as well with a paper to have them look at. If you need, and we talked about that the first couple weeks in class. And so over in the tutoring center, they got some people that'll help you if you need it. Then convert that presentation, and I will make sure the slides all, it might be because I have my resolution's weird on this. But anyway, on the converting presentation, the gist of this slide is that you are not going to read your presentation up here. You're going to convert each bullet point to, or each outline to one of the titles, basically. So if it's intro to Wi-Fi security, title, intro to Wi-Fi security, and then 3 or 4 bullet points on that slide. Then when you're presenting, before you present, let me back up just a second before we get to this one. So when you're converting your bullet points or your outline to a research paper, and again, remember you have 10 minutes. So on average, to get 10 minutes of presentation, you need no more than probably 12 slides. That's about it. So if you have a 6-point outline, let's say, you've got slide 1 is going to be your welcome or your intro. 2, we'll say, is maybe, we'll just put down each page here, and then we'll help you out with that. Each slide page. And we know 12 is going to be, conclusion, and also the normal, is there any questions? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 slides to cover 6 points. And so basically what I generally do is before I even start doing anything, I start realizing, okay, if I want to spend more on point 1 than anything else, I might do point 1 on slides 2, 3, and 4, and then 2, 3, 4, 5, maybe 2 on 5, 2 on 6, something like that. So, and you can always change it, right? You got something to go by, and these numbers here refer to the outline point. And so you know you got your welcome, your outline point, and what I tell students is the ones that have 2 or 3 are the ones you really mean a lot to you or something. You get a lot out of it yourself when you researched, because you get things out of your research that are boring to you maybe, but then there's going to be some that will be like, oh, that's pretty interesting. Those are the ones you want to spend the most time on. And I generally tell students to put that on the front end, because what you don't want to do is put on the back end here and you're running out of time. Say you have only 9 minutes left and they're on slide 9 and you see me say 1 minute left in the back. You're going to have to skip through some stuff. Does that make sense? Yeah.
Can we use any visual aids in addition to the PowerPoint?
Yeah, exactly. You can. In fact, it's on this slide. It's kind of hard to read maybe, but when you're presenting your presentation, you'll be up here with my laptop. Those are presenting that night. You'll bring your PowerPoint in. I'll dump it onto my laptop. You'll have a little clicker to use, and you can click through the slides, or you can sit here wherever you want to. But if you want to use 3x5 cards, you can do that. You can use, I've had students use their iPad as notes to help, their phone. Doesn't really matter to me what you want to use for a tool to help you. What I do recommend, though, is when you're prepping, besides the note cards, if you're going to use those, is to go through it once and time it, whether it be in front of your computer, in front of a mirror, something like that. That way you kind of know how long it's going to take. There is times that you pause longer than you think you're going to, or you go a little bit longer on a point than you think you're going to, and that's going to happen. But you have a rough estimate of how long you need to take on each slide. That makes sense? And roughly with 12 slides, you have a little less than a minute per slide. that's not a long time, but you have to go through it pretty quickly. Does that make sense? Answer your question on that?
Yeah.
Cool. So that's a little Prezi, and I'll make sure that I fix that formatting. I didn't know it was like that. So you'll watch that, and then you'll tell me at the end of the session next week at home, if you do this at home, you don't have to come on campus to do this, just say, what did you accomplish? Hopefully most of you say, I completed my outline. That's the goal anyway. I don't expect you to, start doing, outline and, oh, by the way, I got, 3 out of the 6 points done and read, I don't expect that. But as long as you get the outline done, that'll be a big step, because at least you've got some foundation to do your research paper that will help you in time, believe me. Because if you don't create the outline and you've maybe not done one of the papers in a while, but what happens when you don't create an outline, you're kind of forced to create one anyway in your head, because you start going down all these little trails, right? Those little rabbit trails. And so it'll help you. It will help you. I don't have you turn it in, by the way. I just ask you to create it for your own purpose. Yeah.
You have a suggested link for the paper? I want to know how far.
Yeah, it's actually in the
on there?
yeah, it's in the requirements, the paper length.
Okay.
5 to 7 pages, I believe.
Okay.
And I think we put it in. Let me look here. I think it was in week 1 or 2, but let me look here real quick. It's a good question. I know we went over, but it was way back when.
Yeah.
Let's see, research paper topic. There it is. We'll go down to the. Okay, so it's 5 to 7 pages,
Okay.
excluding illustration bibliography, 1 inch left to right bottom on margin, 1.5 on top, double space for normal text, single for quotes, 10 to 12 point font, file style. I recommend Times New Roman or Courier, and illustrations welcome if good quality. And you don't need a cover sheet, because you're going to be emailing this at the end of the when you're done submitting. When you're ready to submit it, you will email your presentations to 14 to 15, whichever week you're going to be presenting.
Okay.
Good question. Any other questions on next week or the paper presentation? Cool. All right, so let's go ahead and get into the discussion, and then we'll go right into the take-home part, which is using TeamViewer. And we're going to be looking at chapter 10 on remote access, virtual networks and remote access. All right, so everybody's heard of VPNs, and we've talked a little bit about VPNs in here and the reason to use them. This goes over in more detail, the reasons for them and the purposes of VPNs. And the whole reason in today's IT world is virtualization. You'll hear that a lot. Virtualization is taking any type of computer or operating system and emulating it in an environment. In development, for developing apps, we have virtualization for apps for phones and iPads and Android phones and Android devices, where we can emulate a device on a development platform. Same thing with computers. There are emulators that can emulate virtually an operating system. Like an example would be using Windows, VMware would be an example for Mac or PC. Tons of other examples that are used in IT, but VMware is probably the most popular that's out today. There's other ones that are out in the market, but VMs basically are 2 types. There's virtual workstations and virtual servers. Servers are more beefier because they're going to be able to create a larger drive and hold more space and be quicker. Now, when you create a virtual anything, you do add whatever processors you want, like you would in a real computer. How much memory? Now, you are limited to memory and how much physical memory you have on your computer, but you'll create a virtual hard drive, how much memory you want, and then you put the CD in or download the ISO from the website for the operating system and start installing it like you would on a normal computer install. The difference is once you're done creating a virtual environment, VirtualBox is another one I was thinking of earlier. VirtualBox I've used a lot in the Mac world, a lot like VMware. And VirtualBox is available for Windows as well. But the difference between a virtual server and workstation than what you're using today and what I'm using today is it's saved to one file. Everything's saved to one little file that you can put on an external drive and take it to another computer and load that virtual computer in that other computer. You can keep taking it. Like an example for my iOS development students, that don't have a Mac, there's a VMware I created, a VMware image that has the entire operating system for Mac and all of the software they need on that device, on that VMware. So you can configure CPU type, storage drive, NIC, everything, like you would on a real computer. VM appears to user no different than physical. Run the same software. Now it is a little bit slower. Probably it is slower because you're running it in tandem with your real machine. So there is going to be some lagging a little bit for sure. It's not a gaming machine. You don't want to play any games on it. It's not made for that. But you can run the same software you can run on a normal computer, whether it be server or client, that is used in business every day. Host will be the physical computer. Guest is a virtual machine. Hypervisor manages multiple virtual machines. So a hypervisor in VMware can manage this entire classroom of machines. And so I can have everybody's machine on my little computer screen and say that computer over there crashes. I can dump it, delete it, and replace it. And a student just clicks a button and they're back in. And so that's how quick it is. And so a lot of companies are going to virtualization because of management issues. It helps managing. It also with servers. A lot of servers today you log in on websites are virtual servers. They're not real servers, they're virtual. So as technology has gotten better with solid state drives and more memory and faster processors, what I said earlier with being laggy, if you're on a Windows 10 laptop with a quad core processor, yeah, it's going to be laggy, but if you're on a server with 16 processors and 24 gigs of RAM or 32 gigs of RAM, it's going to be sometimes faster than a real native device because of the nature of solid state drive and memory. And hypervisor allows you to manage these quickly and easily. So here's how it works on the virtualization. You've got the physical NIC on your computer, and notice the little computers inside the computer. That's your virtual computers. And IT uses virtual computers a lot to test software, implement, like an example, in updating patches and updating for Microsoft patches and like say Microsoft updates. We update them and look at them in a virtual world that's disconnected from the network to see how it impacts that computer, because these virtual computers in IT would be exact replicas of what clients use in the real world. And if they pass the muster here, then we can release those apps or those updates that we're wanting to release. So advantage of virtualization is efficiency of resources. So one server is not just one server now. One server can be 10 servers with 10 virtual servers inside of them. Cost and energy savings. Fault and threat isolation because it comes down to just one file. Simple backups, one file. You're backing up one file. Now, when you start up that computer or that server, you have everything like you normally would have. When you shut it down, and even while you're running it, it's running off one file. That's it. On VMware, it's a VHD extension, and on VirtualBox, it's a VBX or something like that. Disadvantage: compromised performance. There is a ding in performance. Like I said, even in the fastest server world, it's not made for gaming or whatever, but for processes, it's fine for normal processing. Increased complexity, increased licensing costs because you still have to pay for licenses, but in the virtual world, which can be confusing sometimes. And then single point of failure, meaning if it fails, that's the only place you've got that information, that's maybe not good. And so a lot of sites will have what's called backup VMs, where if one fails, or a RAID VM, if one fails, a RAID of these VMs can take over and immediately, without hiccup, catch, one fails, the other one can take up and take its place. Virtual network. This can be created to create consistent solely of virtual machines on a physical server, which basically, when you set up a virtual computer, it does connect to your physical NIC card for internet. Usually it connects to what's called NAT translation, which is basically using your existing NIC card and bridging it to your virtual environment. And you don't have to do any configurations that way, especially if you're just running a client or something. But the benefit of it too, if on a VPN, you can set up your own private VPNs, your own private subnets, just for VPNs to use, or just for the virtual private networks to use. Virtualization programs, there's tons of them out there, but we'll talk a couple of them already, but assigns VM software and hardware characteristics, usually easy to set up, and usually wizards built into them. Operating images now are available. All of them are available to download because a lot of computers today and servers don't even have DVD drives. Now, I do recommend to students, if you don't have one already, to buy an external DVD drive. That way, if you ever need it in the future, it's good to have around just in case you need it. But almost all, well, not almost every new operating system today is downloadable into one ISO file. And so network connection uses your real NIC card. So here's an example of a screenshot of VMs in VMware. And you'll notice you can put in their memory. In this case, it has a 1 gig memory, one processor, but you can put 4 processors. Connect to the real CD drive, DVD drive if there is one, floppy drive if there is. It shouldn't be one, but maybe, possibly. Network adapter. And notice it says NAT on the network adapter. It's default to NAT translation. And then USB, if there is one, sound card, printer, and display. On the right side just shows a memory, and you'll notice a slider there. And notice where it says maximum recommended memory. In this case, it's 2920 megabytes. And so you generally want to stay below that for your system. So generally, if you have a system that says, is like 8 gigs of RAM like this one, it's going to allow up to right below half, roughly. So about 40% usually is what they generally recommend. So this is grabbing the NIC card and connecting to the existing NIC for incoming and outgoing without doing any type of manipulation to it. So virtual switches and bridges can be created in VMs just like in real world, where you can bridge together VMs to VMs. So an example here is you have an actual virtual switch that you create. Hypervisor will be underneath it, by the way. And notice the virtual switch is connected to virtual VMs, virtual operating systems. It could be clients, servers, whatever. You'll notice the real NIC, though, is connected to the virtual switch, which is that virtual switch is connected to actual other virtual operating systems. Here's an example of a router, a real router, 2 physical NICs on 2 separate computers with a switch in both, connected to 2 VMs on both sides and 2 separate hosts. So in the old days, we would technically only have 2 servers. Now we have 2 servers becomes 4 servers. So a lot more efficient. Network connection types, it's called VNIC in virtual. Most of your stuff, by the way, when you're discussing anything about virtual private networks, virtual LANs, it's always usually the word V in front of it, the letter V in front of it. Frequently used network types is bridge, NAT, host only. The most popular is going to be NAT, meaning you don't do any configuration to the NIC. It just uses your physical NIC configuration on that computer. For clients, that's generally how it's done. So if you wanted to go home and download, say, the latest and greatest Ubuntu Linux distro, you would, download VirtualBox for free or VM Player for free, install it from the download, and fire it up, and you'd have internet immediately. It would connect to your real LAN or real NIC card, and you'd have internet with no configurations. Bridge basically means you're bridging one NIC to the next in a virtual environment. So here's an example of a bridge. You'll notice the IP address of the VM 1 and 2 is different by 1. The left is a 132, the right is a 133. The IP address of the real DHCP server coming from the NIC on the computer is a 131. And so it's bridging it automatically here with the DHCP server and the virtual switch. So there's the network bridge. Notice it says connect when it's powered on, and the network default for this is bridge connected directly to the physical network, like I talked about earlier. NAT is the next one that says used to share the host IP address, and there's no configuration on that one. It's using whatever the host IP address this computer would use. NAT in VLAN or in virtual networks relies on the host to act as a NAT device, obtains IP address information from the host. Virtual software acts as a DHCP server, and the virtual connection type would be like VMware. We've talked about VirtualBox, and the other one's KVM. That's another one as well, another type of virtual software device. Host only is VMs. One host can exchange data with another, cannot communicate with, beyond the host. And that would be helpful when you're testing, like I talked about earlier, with software updates, meaning it's isolated to that computer. The data does not go out of that VM. Doesn't hit your network, which you definitely want that when you're doing any testing, really. It's on a separate, isolated device. Never receive or transmit data with a host physical NIC. So host only is literally isolating it to that VM. Still has internet, still do everything you can do on a normal computer. It's just the data's locked behind that VM. You can't go beyond it. So here's an example of a VNIC on NAT mode. DHCP server is built within the virtual NIC. And you'll notice the IP address of the virtual is totally different than the IP address of the real world. See, the real world is a 192.168. The NIC for VMs is a 10.1. And if we wanted to add another VM, it would add more than likely a 10.1.1.2 or .130 at the end. So here's the different, just like in a real computer, like when you guys look at your NIC cards on your computer, we've got the real NIC, and then we've got 3 or 4 Cisco NICs that we use. Same here, you can add up to 4 NICs to connect and do testing, which is great. And then host only, literally you'll notice you've got your physical NIC plugged into the virtual, but notice the traffic is locked within the virtual environment. The only thing it's there for is connectivity. Nothing's coming out. Virtual appliance, alternate to test servers for new software, like I mentioned earlier, includes the image of the operating system, all the software, everything included. And what I generally do when I create a VM is I'll do this. I do this every semester for my classes for my own use. I'll create a VM for all my classes, and then what I'll do is each semester I will copy the VM, back it up for safekeeping, and say halfway through the semester, which just happens a lot, this one gets all junked up and whatever, I don't have time to clean it up. I just back up the data that's on this VM. I'll dump it into a external drive or cloud drive. I'll kill that VM, take that copy, restore it, and then move the data back. Move the data back to the one I just copied. Done. So what normally would take, and I know you guys done this before, had to reformat a computer and install the software. Well, if you do it this way here, I just mentioned, yeah, you got to do that the first time. But if you do it right, you're literally only having a copy of one file, and you're up and going again. Done. It's just a time to copy, and it's a large file. I'm not telling you it's not. Most VMs I have are anywhere from 20 gigs to 40 gigs to 60 gigs to 70 gigs. It can be, depending on what I have on it. Does that make sense? And so, but data, hard drive space is dirt cheap today. Like even SSDs are external SSDs are very inexpensive. Very inexpensive. You can get a 4 terabyte, 3 terabyte external drive for 125, 130 bucks. It's really, really inexpensive. And you can get a lot of VMs stored on that, by the way, too. Does that make sense? And that saves tons of time. And you might be thinking, well, do a lot of IT departments or people, are they working only in the VM world? Yeah, they are. They're just using the computer to have the base install, right? So Windows 10, right? That's it. Nothing else. So you don't want to use any more hard drive space or memory than you need to, right? And then you start loading on there your VMs. And you could have 5 or 6 different operating systems running. All of them doing certain different things. You could have Linux, Windows, Mac. You could have, the whole ball of wax, all in one computer, right? Now, it gets kind of confusing in the fact that you can now get VMs on the cloud. Microsoft has Amazon's the largest provider of cloud services and will be forever probably. But, and it's getting pretty reasonable for businesses to do that. There's actually businesses now doing that, hosting when their employees log in the morning and throughout the day, they're on a cloud device. They're on a cloud operating system. And it does work. The problem is what you think. What's the problem with a cloud only type of setup? What is it? Yeah. So when it goes down, now granted, most of them have a thing where they say, 99.99% uptime, which it's true. It is. But what about that 100th of the time it's not? It's not, Yeah, you're with a client and you can't connect. So what companies do that are totally on that cloud type of VM, they will have a fail safe. They'll have a backup for sure, right? That way, if it does go down, hey, they've got something local that they can use. So it might not have everything they have on the cloud at the time, but they can, the data is going to be there if they need, if that makes sense. So most commonly, virtual servers uses would be firewall. There's a firewall package you can download called pfSense. It's a Linux package that you can install on a VM. It's a great free open source firewall. Email Solutions as another VM. Most companies are merging all of their Exchange email to a virtual server. Network management, same. So Active Directory, virtualized. Remote access, that you're going to do this week, all remote, coming in virtualized. So virtual networks and VLANs. Virtual networks refer to how VMs connect to other virtual and physical networks. Nearly identical to physical network layout. To add a VM to physical LAN, you just need to modify the virtual switches configuration. So make sure it's in the same IP range and same subnet, and then they can talk to one another. And I'm running low on battery, so better plug in my computer. Died my power cord. All right. And by the way, talking about power, when you use VMs, they do consume more power on your computer than when they're not being used, just because your computer's not only powering it up for itself, it's also powering it up for the VM that you're using. Does that make sense? So you're going to be using more power. But if you think about it, yeah, you're using more power, but now one server can actually be 2 servers or 4 servers. So yeah, you might be for that one, but if you subdivide it amongst the 4, you're actually saving money probably, if that makes sense. So 4 virtual servers and 1 real server is probably cheaper, definitely cheaper electric-wise than 4 separate servers, right? So this example here is just talking about showing how multiple virtual servers can be connected to multiple VLANs. And a VLAN is basically a network that is divided from another network. Like here on campus, we have VLANs for data, VLANs for voice. So when you're on your computer, that's data VLAN. When we're on the phone, it's voice VLAN. They don't talk, they don't come across one another. Does that make sense? When I first started working here, we had what's called a flat network, meaning everything's on one IP address range. So there would be times when you would pick up a phone midday when everybody's on the network and something had to give. So generally in that case, the call would get dropped. And so we moved eventually to VLANs. But you can have multiple VLANs even in the virtual world, like it has up here on the screen. And you'll notice each VLAN is a part of a different port group is what it's called. So you have port group 120, 121, 122, 123, all doing certain functionality. And generally VLANs are designed to subdivide traffic on your network and to keep them separate. That's what it's for. Okay, so that way you don't collide and you have dedicated lanes for each traffic that you need. Now we're getting into fun stuff we're getting ready to talk about, even though VLANs I think are fun, is remote access we're getting ready to do tonight. Now, how many's never used remote access anything? You've never used remote anything. You've never remoted into another computer from one computer to the next. You've never done that? Okay, cool. Thank you. It's a lot of uses for it today. A lot of workplaces will have their employees log in. Like my son lives in Springfield, Missouri. He used to live here in Rockford, but when he was going to move to Springfield, and he was going to put his notice in. He was, ready to put his notice in, and he was a manager here at a company, and the boss said, "Well, why do you need to put your notice in?" He goes, "Well, I'm moving to Springfield. I can't manage my people. I'm going to be in Springfield." He goes, "You can't do calls every day," and he goes, "Well, I don't have that set up." He goes, "We'll set it up for you." So they sent him a voice over IP phone, computer, it all set up. So he managed people there for 5 years remotely, had daily calls, video, just like he was in the building. They would call a four number extension. It would come to his phone in Springfield, and vice versa. He did a 4-digit extension, becoming here in Rockford. Now he's more in sales, but still, with virtual access, it's freed up companies to do what they did for Mark, which is when they have a good employee, or they have somebody that needs to travel, they can work wherever now. There's no limitations, right? Distance isn't a problem anymore. So remote access allows you as a user to connect to a LAN or WAN in a different geographical location, like Mark in Springfield to Rockford. Now, what's funny about their company is their servers are actually in Georgia. Their remote servers are in Georgia. So when he logs in the morning in Springfield, he's actually logging into Georgia. Same with the Rockford's logging into Georgia. But they are doing a lot of all their data and virtualizations in Georgia. It does require a transmission path and appropriate software for remote access, like one we're going to be using tonight. Popular remote or dial-up networking, not so much, but it used to be. When I first came on campus, by the way, all faculty and even students got limited dial-up access to the campus. Dial-up access to the campus. Anybody go to college back then, by the way, that's in here? I guess it's only you and I can say. But anyway, you used to be able to dial up to the campus, right? And when you dialed up, you would get connected, and then you would start, doing your work on the server and put my stuff on this class site. But, a 5 meg file took about 20, 30 minutes to upload versus today, half a millisecond. But believe it or not, they just killed that modem, that dial-up modem 2 years ago. It was active up to 2 years ago. There was still faculty using it. Yes, because if you connected to it, you didn't have to buy internet connection, because when you connected to it was that you did get internet connection. Now, granted, it was very slow internet connection, but it was internet connection. even though it's like, 20 kbs a second or something like that. It's crazy. It's like really, yeah. But yeah, there's some still using it, but whatever. They finally killed it. Microsoft has one called Microsoft Remote Access Servers. It's still around, but not very popular. It's still built into the operating system. And then VPNs, multiple VPNs out there. Cisco is probably the most popular VPN. Citrix is a big one. Citrix is a huge VPN network setup, whereas a Citrix server and a Citrix client, where companies log in, folks log in. Dial-up networking, the way this worked was you would dial up via modem and connect, log in with your network password and username and log in. Very low throughput, less popular today because of, high speed for sure. Remote access servers, it would have its own dedicated server at the location. A Microsoft server would be set up for it. Again, not real popular, hard to set up, very difficult configurations, and not real fast either. So, but here's an example of clients connecting to remote access. So you have your clients in the cloud working all over the world. They're on the lower left, and they're connecting via whatever connection they have. It could be Xfinity, Frontier, Verizon, AT&T, it doesn't matter, whatever it might be they're connected to, right? That's the cloud. Then you'll notice it hits the remote access server, okay, which then allows them to connect to the router in their company, printer, web server, file server, everything, right? So what you're basically seeing, you're not losing your desktop, by the way, on your computer. You're just getting connected to that network on your workplace, if that makes sense. So you get to see all the drives they have there. Unlike we're going to do this week, you're not remoting into a computer to see a desktop like you would have at work. You're just getting connected to that network as if you were in the building. If that makes sense. So some of the protocols in remote access is serial line internet protocol, SLIP, which is basically early, less sophisticated, can carry only IP packets, requires a lot of setup, did not support, still doesn't support data encryption. Asynchronous, point-to-point, known as PPOE, used over the Ethernet, stand for connecting home computers to ISP via DSL or broadband. Point-to-point is still the most popular today with VPNs. And then remote virtual, we're getting ready to do. This is where you basically remote into a computer from anywhere in the world. So you remote into a work computer, remote into a home computer, and you can use your tablet, phone, or whatever to remote in, and then do your work as if you were sitting right there working on it, right? You can send keystrokes just literally as you're sitting right there. Basically, it's a thin client where a workstation uses software to access a LAN, requires very little hard disk space and processing power. Because like in the TeamViewer thing we're using, it's a really small application, and it creates a tunnel, a secure tunnel, to your computer. But on your computer at work or home, you have to set up that same software to say, okay, I want this communication to work. In the middle, though, here is TeamViewer's cloud services. So you have your client here at home, work. TeamViewer is a middle guy that's used as an intermediary device between the two. For end users that are non-business users like yourself, it's free to use. For commercial use, it does cost, but it does save people a lot of time and money by remoting in, because they don't have to get out of their house, or they don't have to move from their location, and they can be anywhere, anytime, basically, to do work. So remote access software builds upon the OSI model. You have the bottom level, which is the Ethernet level, which is the physical, the PPP level, data link, IP network, TCP transport, and then the actual software falls on that application layer. And remember, on the discussion we have with OSI, application layer isn't actually a real application, but it talks to applications. It's just that layer, that's where this remote access software falls on. Advantages of remote virtual computing: simple to configure, you'll see this week, runs over any type of connection, Single host can connect, accept multiple simultaneous connections from a client, multiple clients. Microsoft VNC, which we'll use here in a couple weeks, and then internet computing architecture, and then the one we're using, which is TeamViewer, is probably the most popular today. Remote desktop comes with a Windows client and server system, both server operating systems. VNC is open source, and VNC is really good for like internal use only, not really good over the WAN, over the internet. It's really good for help desk type stuff though, because it's free to use, it's easy to set up. It's a little clunkier than TeamViewer, you'll see when you play with it, but it works. And then Citrix is the bottom one, which is definitely more expensive. And Citrix can work with virtually any operating system or application. And there is a server for Citrix you have to set up, which that is expensive. And but a lot of companies use it because it's very robust. Okay, very robust and a mature product. So on the VPN, basically, it can be subdivided over public transmission system, over public lines, over Xfinity, Comcast, whatever. Requires very inexpensive software. Important considerations are security and interoperability. How does it work? Does it work with all your devices? That's a big thing to find out. There's two types of VPN, site-to-site or client-to-site. So here's an example of some VPN, site-to-site. So we have different offices, right? Like Pepsi has this, Coke, Sears, JCPenney, any big store that has a chain, McDonald's, a whole list of stuff, right? So all these different locations, all connected through virtual circuits in a point-to-point, site-to-site VPN. So at the end of the day, all transactions go to whichever one's the mothership here, to all sales go to it, end of day numbers all go to one of the locations normally. Like at Microsoft, you got Seattle, and then Apple, Cupertino. And so at the end of the day, all the daily sales for all the Apple stores go to Cupertino, I'm sure. Pepsi, it's Tulsa, Oklahoma. So all the Pepsi distributors at the end of the day send all their sales to the Tulsa, Oklahoma location, all through site to site. And generally on the site to site VPNs, a lot of times they will pay for direct lines. They'll pay extra money for sometimes direct circuits, direct physical T1, T3, T4 lines in between those sites. So this is an example of like a consumer like ourselves connecting from your house to a work office. So you've got Xfinity at your house. You're connecting through their little, maybe let's say you're using Citrix at your work, and you're logging into the Citrix server there, the remote office in Raleigh, and being able to connect. And they can do via mobile as well. And then notice here, the Charleston office has a VPN gateway that is connecting basically all of the offices one to the other, which would be the remote office in Raleigh and the home office all together. So that VPN gateway could be Citrix, it could be a Cisco gateway for VPN. So a number of different products that are out there. So there's VPN gateways, enterprise-wide type of gateway that includes client to site, site to site. It can tailor regardless where the company location or the user's at. Could be in Japan, could be in China, Germany, doesn't matter. And the two types, point-to-point and layer 2 tunneling. Now the point-to-point layer 2, point-to-point is probably going to be the most popular. The layer 2 tunneling can be a little more expensive. And then cloud computing. We talked a little bit about this already, but internet frequently pictured as a cloud. Cloud computing is flexible. It's everywhere. Data storage, application services. Google was probably the first one out of the chute with cloud services, well, cloud applications. But now, everybody's got it now. Everybody has cloud services from entire operating systems to just unique applications. Cloud services help, you can self-service. You can add applications as you need them or services. It's very elastic, meaning it can grow or shrink. Supports multiple platforms regardless of what the devices are, and its resources can pull together. And it's a metered service, meaning you only pay for what you use. So an example of a cloud service here is you've got a cloud computer out there on the server. It's a virtual cloud computer. And notice you have everything in it you have in a normal server. You've got the server operating system, backups, applications that are needed, storage that's needed, access control, and then all the ones outside of the cloud are the ones connecting to that service. And all different devices, could be old devices, new devices. Really doesn't matter because you're actually connecting most of the time through a browser. There's really not need for any software anymore on cloud services, which is nice because you don't need to download any plugins or any updates. It's all cloud-based. It's all a web portal that you log into and you can get access. So cloud computing can provide virtual desktops. And so you can have the operating system be hosted virtually from anywhere, and it can be different physical computer than others using within the network. NAS, which is a network as a service, is where the service providers offer customers a complete set of networking services. And there's types of delivery for cloud, which will be public and private. Google would be a public cloud, a popular one. Amazon does have a public service, but private would probably be more on the Amazon Microsoft level. Public would be more of as far as wide use, probably Google, I'm guessing, than the other. So virtualization is something that's popular. Remote access is popular because with virtualization, you can utilize hard drive space more. One server can become 4 VMs. One computer can have multiple VMs as well, and we can back those up and restore them as we need to. We can also, on remote software, remote into both servers that work or cloud without much resources on our end, just a small client that runs. So let's do this. If you'll go to week 8 lab, we're going to go over a document in there. It's called Step-by-Step Team Viewer. And let's open that up and look at it. It's a PDF, I believe it should be when it downloads. And we'll look up it together. We'll go over the document together, and then I'll tell you what you need to do before you leave. This is a take-home, so you'll be working with a team member. If you look on the overhead, on that link there, right here, if you right-click on it and open link in new tab, try that. And then click on that tab. It should blink, and then you should be able to download it. Oh, are you on IE? Yeah, you're on Internet Explorer. You want to be on Chrome. Internet Explorer. If you're on Chrome or Firefox, yeah. So what log you're into, you don't count that. Everybody else be able to download it? Okay, cool. So yeah, he was using IE. That's what caused it. All right. So let's go over that PDF. So first step, or first thing it talks about is the top step-by-step desktop with Team Viewer, remote desktop Team Viewer. We're going to do a step-by-step guide. The first thing you'll do when you get home is you will download Team Viewer, the full version from that website on step 1. Step 2, you will double-click on the file downloaded in step 1. Follow the following screen wizard. There'll be 3 options on the proceed, by the way. You're going to choose the bottom option where it says, how do you want to proceed, which is run one-time use only, run only, one-time use only. Now, after you do this lab, if you decide you want to install this on your computer, the middle one's the one you want to select. That way it's what's called an unattended install. Unattended install, meaning once it's installed, you can then install TeamViewer on any other device and log in to your computer at home. Okay. But for the lab, we're just going to do the one time. But if you want to use it after the lab and you're like, wow, I don't really like this, I think I'm going to try it. The middle one there is the one you want to choose to install. Okay. Once you install it, by the way, it's different than what you're going to do in here a little bit. It will have you sometime, if you want, you can add, and I recommend adding an access code to where not only are you having to enter in the password for TeamViewer, the username and password for TeamViewer app, you're also having to put in a passcode before you even get to your computer to log in. Does that make sense? So I recommend doing that just for one safety step there. The second one, where it says, how do you want to use TeamViewer? This is important. Make sure and check the middle, which is personal non-commercial, because if you check the top one or the bottom one, they will prompt you to pay for TeamViewer. So make sure and only select the middle one, which is personal non-commercial, which that's what we're using it for. And then you'll click the accept run button. Step 4, you'll close it because I just want to make sure you know how to run it. Now you're ready to remote or be remote control. Step 6, set up time and date when both of you will be able to connect in your team that you'll get within a second. And you remote control each other's PC or Mac. This works with PC or Mac, by the way. You'll decide who's going to be the expert, the person remote controlling, and who's going to be the user, the person being remote controlled. Now, if you want to kind of do both, where you want to play both roles, that's fine, but you're not required to do that for the lab. If you want to do that, I've had a lot of students do that just to kind of play with it, see if they, see how it works on both sides. You can definitely do that. So to begin the session, both of you will start TeamViewer. You'll run step 2 and 6 from above, and then the user will call the expert and give them the ID and password. Because when you run TeamViewer, it'll give you an ID and a password. You'll need to give your helper that information. You can text it to them, you can email it to them, however you want to do it. You guys can figure that out. B, once connected, the expert will start Notepad or TextPad on a Mac on the user client. C, the expert will type in Notepad or TextPad their first and last name, save it to the desktop. The expert will also set the home page of the user's internet browser to myreceipt.org. So probably a good idea before you do this, those of you remoting into another person's computer, to figure out what browser they have before they leave tonight. That way you can do some research on how to set the home page to myreceipt.org if you don't know how to do that already. It's not real hard. You just Google it and it'll show you how to do it. Then you'll end the session. Step 7, you'll send to Dropbox for week 8, title it Remote Lab, describe your experience using TeamViewer, and how you might use it in the future. Now let me look at that week 8 lab. It's a text box entry in the week 8 lab, meaning I'm just going to have you copy and paste your experience, or you can just type it in. It shouldn't take you too long. You're just going to type in your experience with TeamViewer and if you basically would use it in the future. Make sense? Questions? So go ahead and get with at least one other person around your area. You can work with more than one person, but I want everybody to be paired up before you leave tonight and set up a schedule time. Okay? And again, if you're in an area that you have 3 people, more than likely one person is going to have to work in 2 groups. But that's fine. So whoever wants to volunteer to do that, just say, okay, I'll do 2 groups. I'm fine. All right. So everybody got to get a user. Go ahead and look at your neighbor and say, yeah, let's do it. Set up your date and time, and also set up what browser that user is using. And if you want to do both, be a expert and a user both, that's fine. You guys can definitely do that.